The most common mistake is to see the display turn on and assume the controller failed. But that symptom only tells you the power path broke somewhere. The bike is awake, yet the drive path is not completing. So before you buy a controller, step back and ask what stopped the command from reaching the motor. That question saves time and keeps you from replacing the wrong part. Think of assist as a chain, not a single part. The battery has to supply power, the BMS has to allow it, the controller has to read the inputs, and the display, brake cutoff, throttle or PAS, wiring and motor all have to agree. If one link breaks, the bike can still power up but refuse to drive. That is why one symptom does not prove one failed part. When you press the ride command, the signal starts at the display or input and moves toward the controller. The controller then decides whether to send power onward. If the command never reaches that point, the motor stays silent. If the controller gets a bad signal, it may hold back. So the question is not just, does it turn on, but did the command actually arrive? The controller is waiting for permission. It needs clean power, valid inputs, and no safety cutoff before it sends current to the motor. That means a missing response can come from the supply side, the input side, or the controller itself. When the logic chain is broken, the motor does exactly what it is told. Nothing. That is why the next check has to follow the permission path. In a normal path, the command moves through the system and the motor responds. In a fault path, the flow stops early. It might stop at the input, a connector, the supply, or the controller output. That split matters because the symptom can look the same on the handlebars, but the cause changes the fix. So now we compare what should move with what actually moves. A loose or partly seated connector can imitate a dead controller, so look at the external contacts first. Check for corrosion, moisture, bent pins, or a plug that never fully locked in. If the connection is unstable, the controller may lose the signal or power for a moment and shut down assist. That is a simple place to look before replacing electronics. Keep bike design differences in mind though. A controller symptom can still start at the battery. If the battery voltage is weak, unstable, or being limited, the controller may never get the supply it needs to drive the motor. So the display can look normal while the drive side fails. That is why supply comes before blame. First confirm the battery can actually feed the control system under load. The BMS acts like a gate inside the battery pack. If it sees a problem, it can block current to protect the pack. From the outside, that can look just like a bad controller because the bike powers up but will not drive. So if protection is cutting supply, a controller swap will not fix the real issue. The battery path has to stay open first. A brake cutoff is designed to interrupt motor output when the bike thinks braking is happening. If that signal is stuck, the controller may refuse to assist on purpose. A throttle or PAS input can also fail before the controller gets a valid command. So do not bypass safety parts casually. Check whether an input is blocking output before you assume the controller has failed. Now the clues start to separate the branches. If the display shows an error, that pushes you toward a specific fault path. If throttle does nothing but PAS still works, or assist cups in and out, that changes the odds again. A full no assist symptom points differently than an intermittent one. So watch the behavior pattern. It is often more useful than one part label. Use the symptom pattern to sort the problem. If the bike has no response anywhere, the supply or controller side moves up the list. If one input works and another does not, the issue may sit in the sensor path or wiring. If the assist cuts only under motion, the motor or sensor branch becomes more likely. The goal is not certainty yet. It is narrowing the next check. Battery seating can look like controller failure because the controller only works if the battery contacts stay solid. A pack that is not fully seated or contacts that are dirty or worn can break power for a split second and shut the system down. So inspect the battery rail and the contact points. This is a simple external check that can explain a very misleading symptom. Here is the costly trap: buying a controller before proving the signal and supply path. A lot of riders swap the expensive part first, then discover the real issue was a loose connector, a blocked input, or a battery contact problem. The symptom can point at the controller, but the evidence has to earn that conclusion. So do not spend money until the chain is actually tested. If you see damaged wiring, melted insulation, exposed conductors, or heat damage, stop the home diagnosis there. That is no longer a simple check the plug situation. A fault like that can spread, short, or create a safety risk. At that point, the safest move is to stop and get professional help. Do not keep powering the bike just to see what happens next. The same control logic can live in different places depending on the bike design. On one bike, the controller may sit in the frame and the cutoff sensor is easy to reach. On another, the wiring path is tucked inside and the display tells you more. So the checklist stays the same, but the physical layout changes. That is why you have to follow the evidence on your own bike. By now, the evidence should point to one path. If the connector or input looks weak, check that branch first. If the battery supply looks unstable, stay on the supply side. If the inputs look clean and the bike still will not drive, the controller output becomes more suspicious. If the situation is unclear or the wiring looks risky, stop and verify with a professional before replacing parts. Keep the order in mind. Symptom first, then control path, then safe external checks, then input clues, then the decision fork. Do not jump straight to the controller just because the bike will not move. A display on, no drive symptom can come from the battery, the BMS, the brake cutoff, the throttle or PAS input, wiring, or the controller. The evidence decides the branch. If you want the full checklist, check the related guide, or leave a comment with your exact model and symptom. That helps narrow the path faster, because bike designs vary, and the same behavior can come from different places. The key takeaway is simple. Confirm the signal path before replacing parts. That keeps the diagnosis practical, and it keeps you from buying the wrong fix.